Hello class, and welcome to Notes 6.7a, Graphs of Linear Inequalities. Our objective today is to graph linear inequalities. Make sure you write down our standard, Algebra and Functions 1.1. For vocabulary today, we have 3 vocab words that I need you to write down, as well as their definitions. Linear inequality in 2 variables, an inequality in which the variables appear in separate terms and each variable occurs only to the first power. That one's going to be a little confusing right now, but I will be going over that. Solution of a linear inequality, an ordered pair that makes an inequality true. So that's just going to be whatever you get for your answers, your ordered pair, your x value, and your y value. A half plane is a kind of a different one. It is the graph of the linear equality in 2 variables. Because you're going to be doing some shading on these graphs, the half plane is going to be either the side that you shade or the side that you don't shade. And again, I'll be explaining that in just a few. So let's go ahead and take a look at teacher example 1. Make sure you just have your pencils down and just follow along. Tell whether the ordered pair is a solution of 2x minus 7y is greater than negative 3. So what you need to do is I've given you some ordered pairs. All you're going to do is plug them in and see if they work. Remember, the first value is the x value. The second value is always the y, and I set it up in our chart this way, reminding you that it's x and then y. So instead of x, we're going to write 0, and instead of y, we're going to write 0. We're going to multiply and then subtract. 0 minus 0, of course, is 0. So all of this whole group of terms, when you combine it all, it just combines down to 0. So all you really have is 0 is greater than negative 3. And that is true, so your answer is yes. That ordered pair is a solution. You're going to do the same thing here on problem number 2. Plugging your numbers in, multiply, and then subtract. 4 plus negative 7, because of course it was 4 minus 7, so I did skip, change, change. And you end up with negative 3. Negative 3 is greater than negative 3, and of course we know that is not true because it is equal to negative 3. Okay, and finally, negative 2, comma 1. Plug our numbers in and solve, and we end up with negative 11. Negative 11 is greater than negative 3, and of course that is also not true. So our answer is no. Okay, so all you're doing is plugging your numbers in for those variables and solving, and then just seeing if the statement's true. One part I do want to warn you about, make sure you include the inequality. Problems like this one here, a lot of students tend to make mistakes because they use an equal sign. Negative 3 is equal to negative 3, but that's not what the question is asking. So be careful on that. Okay, go ahead and go on to student practice. Tell whether the ordered pair is a solution of the equation 4x plus 5y is greater than or less than or equal to negative 1. Watch out for that or equal to sign. It's kind of hidden right there. Okay, so go ahead and solve. Press play when you're ready to see the answers. Okay, let's take a look. Plugging your numbers in, you end up with 0 is less than or equal to negative 1. And of course, your answer is no, 0 is not less than any negative number. Problem number 2, you plug your ordered pairs in, and negative 1 is less than or equal to negative 1. That is true because of that or equal to sign. So because it has a line underneath it, it does make it true. So you want to watch out for that. Number 3, plug your ordered pair in. We end up with negative 2 is less than or equal to negative 1. And that is true because as we know, our negatives are backwards. So negative 2 is actually smaller than negative 1. Finally, plug the 4th ordered pair in and solve. 1 is less than or equal to negative 1. We know that's not true. No positive number is smaller than a negative number. Okay, hopefully you did all right on that one. Go ahead and fix your answers if you need to. And let's go on to the next page. Okay, here I have some steps for you for graphing inequalities. I do need you to write down all of these steps. It's very important you write them down carefully. I would highlight them, circle them, star them in your notes, whatever you need. Remember, when you get to a big quiz, this will be very helpful to make this easy to find in your notes. So you want to change to slope-intercept form. Again, that's y equals mx plus b. Find and plot the m and the b. Then you need to decide whether it's a dotted or a solid line. And we've talked about in the past, whenever you're graphing an inequality without an equal sign, it is exclusive, so we use a dotted line. Okay, meaning it can't be that line. And whenever you have the or equal to, less than or equal to, greater than or equal to, of course, simply equal to, you use a solid line. Finally, step 3, pick a test point. For example, 0, 0 is a nice easy test point to do. And you want to test it out and then shade it. Okay, so make sure you've written all this down. Again, this may be a little confusing for you, but as we go over it, it will make more sense. Okay, so let's take a look at teacher example 2. Graph the inequality y minus 6x is greater than 8. So the first thing we want to do is turn it into slope-intercept form, y equals mx plus b. So of course we need to move the minus 6x. So we add 6x to both sides, and we end up with y is greater than 6x plus 8. Remember, we talked about in order to get it in the right form, the 6x needs to be first, and the constant, that 8, needs to be on the end. So we set it up this way. Okay, so of course, my m is the 6, and the 8 is the b. So I'm going to plot those, and I'll go ahead and show you the plot in just a minute. But as you know, you're going to go up on the y-axis to 8, and then you're going to count up 6 over 1, because of course the m, you think of it as a fraction, 6 over 1. Okay? And after that, you're going to determine that it is a dotted line, because we do have that, you do not have the or equal to sign there. And then finally, you're going to choose your test point. As I've said, I always use 0, 0, unless 0, 0 happens to be right on the line. So 0, 0 is that easiest test point. So plugging 0, 0 into the equation, 0 minus 6 times 0, and of course 6 times 0 is just 0. So I've got 0 minus 0 is greater than 8, which means 0 is greater than 8, which is not true. So that means you want to shade away from 0, 0, the opposite half plane. So let me go ahead and show you my graph now. Okay, so if we take a look, notice I went to 8 on the y-axis, up 6 over 1. You do want to be careful if you're skip counting, make sure you're counting carefully. Notice I only skip counted on the y-axis, not on the x-axis. Okay, I can also do the reverse. If I make the slope negative over negative, I can go down 6 and backwards 1. Then of course I used a dotted line. And then notice the point 0, 0 would be right here. So what we're looking at is 0, 0 is on this half plane. So this half of the graph that's on, I guess, the right side of the dotted line, the lower right. All of this includes 0, 0. And when I tested that 0, 0 out, I found that it did not work. That point didn't work. So instead I shaded on the other side, and I do apologize for my shading. It was a little tough doing it with a computer mouse. So let's go ahead and give you some to try out. These may be a little tricky for you, so take your time, and when you're finished, go ahead and check your answers. Don't forget to do your test point and your shading. Okay, let's see how you did. This problem is already set up in the correct form. Y equals mx plus b. So my m, of course, would be a 1 right here. My b would be -9. So I plot my point at -9. And then if I turn 1 into a fraction, of course, it would just be 1 over 1. So up 1 over 1, up 1 over 1. I will be using a dotted line because I do not have the or equal to line underneath. Then lastly, I'll test out the point 0, 0, plugging in a 0 for y and a 0 for x. 0 minus 9 is -9, and it is true. 0 is greater than -9. So I'm going to shade to the side, including the 0, 0. So if I look at where my original point was, right here at -9, up 1 over 1, up 1 over 1, up 1 over 1. Then I have my dotted line, and then I shaded so that I was shading right over top of that point 0, 0. And this is a little tricky, so be careful when you're doing that shading. Make sure you pay attention to which side the 0, 0 is on. Okay, problem number 6. I need to get it in the correct form, so of course I need to move the 1/8 x. So I can subtract 1/8 x on both sides and end up with y is greater than negative 1/8 x plus 5. So my m is right here, my b is on the end. Then I need to do my test point of 0, 0. 1/8 times 0 is 0, which is again why I use this as a test point. You can test out any point on the graph you want. For example, in problem number 5, I could have picked this point here, or this point here, or this point here, or this point here. It doesn't matter which one you choose. I always choose 0, 0 because zeros are so easy to work with. So here I end up with 0 plus 0 is less than 5, which of course we all know that 0 is 0 is less than 5. So my answer is yes. So when I take a look at my graph, I've plotted my point at 5 on the y-axis, right here. And now, because of the negative sign, I go down 1, forwards 8. Down 1, forwards 8, put my next point. I do use a dotted line because it has that or equal to. It does not have that or equal to. And then, because I got yes, I want to shade. So again, my green coloring can go right over that point 0, 0 because it did work. Okay? So these are very tricky, and again, we'll be spending a couple days on these. I don't expect you to get these right away. But go ahead and go over those answers, and then please take the quiz. On this quiz, you're not going to need to do any graphing. All I'm asking you to do is come up with a yes or no answer, telling me whether the ordered pair is a solution of the equation 2x plus 3y is less than 5. Okay, have a great day.